13 of chapter 4 series. Now in this video we are going to continue the exercise of chapter 4. Now first question is exercise question number 4.10. The question is like this: in a reaction between A and B, the initial rate of reaction R0 was measured for different initial concentration of A and B as given below. What are the rate of what are the rate of reaction respect to A and B? Okay, so here in question we have different initial concentration. These are initial concentration, but concentration are different here. Different initial concentration is taken here. Now for that, the rate of reaction is given to us for the initial reactions, initial concentrations. Now we have to measure order of reaction here. We have to measure order of reaction with respect to A and B. So here suppose the rate of reaction is given by rate is equal to K into concentration of A raised to X into concentration of B raised to Y. That is our equation for rate. Now for first experiment you can see the concentration is 0.2 for component A, concentration of component B is 0.3, and R0 that is given to us 5.07 into 10 raised to minus 5. So these three value we have, only X and Y that we don't have. So put these three value in the equation. So I have written that values here. 5 into 10 raised to minus 5 is equal to K into 0.2 raised to X into 0.3 raised to Y. Similarly for experiment number 2, same thing I have done here. The concentration are given us in table 0.3, 0.2 sorry 0.2, 0.1 and 5.07 into 10 raised to minus 5. These three values are given to us, so put these three value in the equation. You can see here 5.07 into 10 raised to minus 5 is equal to K into 0.2 raised to X, 0.1 raised to Y. Similarly for third experiment, the value are here 0.4, 0.05 and 1.43 into 10 raised to minus 4. This is 10 raised to minus 4. So that value I have written here in equation number 3. Now divide first equation by second. 1 divided by 2. So here I have written that 5.07 into 10 raised to minus 5 divided by 5.07 into 10 raised to minus 5 is equal to K into 0.2 raised to X into 0.3 raised to Y divided by K into 0.2 raised to X into 0.1 raised to Y. Now you can see this value are same, so it will be 1 here. So here I have written 1. K and 0.2 raised to X, both are same here, so that will be cancelled out. So what we have left here, 0.3 divided by 0.1 whole raised to Y, both are having power Y, is equal to 1. Now in what condition this is possible? If the power of both is 0, then we can get one value here. Both are having same power. Now that power must be 0 to be equal to 1 here. So from this equation we can say that value of Y is equal to 0. Why 0 we have taken? Because value is 1 here. Now same thing we are going to do again here. Here, divide third equation by 2. You can see third equation 1.43 into 10 raised to minus 4 is equal to k into 0.4 raised to s 0.05 raised to y. So that equation I have written, divide by equation number 2. Now 10 raised to minus 5 and 10 raised to minus 4 are here. So what I have done, 10 raised to minus 4 will be cancelled out. Only 10 raised to minus 2 will, minus 1 will be left here. Minus 4 and minus 5 are there. That's why. So 1 point I have written ahead here, 0.507 I have written. Now on other side you can see k will be cancelled out. Similarly y is equal to 0, we got that. So this value 0.05 raised to y raised to 0 means 1. Similarly 0.1 raised to 0, that is also equal to 1. So I have not written that values here. Only this much value will be left, 0.4 divided by 0.2 whole raised to x. Now this division you will get 2.820 is equal to this division 0.4 divided by 0.2, that is 2 raised to x. Now take logarithm on both sides. So log 2 is equal log 2.820 is equal to log 2 raised to x. Now x is in power of 2, so that will come in multiplication, and log 2.820, that is 0.450 value of that log. Now from this equation you can make formula for x. X is equal to 0.450 divided by log 2. Log 2 value is 0.3010. So this division you will get 1.49, that is almost equal to 1.5. Hence we can say that order of reaction with respect to component A is 1.5 and with respect to component B is 0. Next, question number 4.11. Question is like this: the following results have been obtained during kinetic studies of the reaction. 2A plus B gives C plus D. Okay, experiment number, concentration of A, concentration of B, initial rate of formation of D. Determine rate law and rate constant for the reaction. Okay, so here a reaction is given to us, 2A plus B gives C plus D. Now for that reaction, number of experiments is performed here. Now concentration of A and B both are given to us, and initial rate of formation of D, that is also given to us, means rate is also given to us. We have to find out the rate law. Rate law, what is that? So relation between rate of reaction and concentration of reactant, relation between that two, that is called rate law. So here suppose our rate law is this equation: rate is equal to K into concentration of A into concentration of B raised to concentration of A raised to X and concentration of B raised to Y. We are going to derive this X and Y here. Now for first experiment, concentration of A, concentration of B and rate value we have. So put these three value in equation. So here you can see that three values I have written in equation. That is our equation number 1. Similarly, for second experiment, three values are given. Put these three values in the equation. That is our equation number 2. Similarly, for equation number 3 and equation number 4. That four equation we have now. Now, what I am going to do here, divide fourth equation by first. So, here I have written that two equation. Now, this division you will get 4 is equal to, you can say k are same, and 0.1 raised to y, 0.1 raised to y, they are also same. So that will be cancelled out. Only 0.4 raised to x divided by 0.1 raised to x is there. Now you can see both have same power. So this division is possible. 0.4 divided by 0.1. That division you will get 4. So from this equation you can say that x is equal to 1. Now similarly divide third equation by 2. Now that mathematical equations you have to write down in your example. I have not written here. That calculation you have to do in your notebook, and you will get y is equal to 2. That calculation you have to write down in your notebook at your own. Now we have x and y value, so we can say that our rate is equal to k into a raised to 1 into b raised to 2. Now you can see here second question that is asked is for rate constant. Rate constant k also we have to find out. Now for that, for experiment number 1, now this calculation is for k value here. For experiment number 1, concentration of A is equal to 0.1, concentration of B is equal to 0.1, and rate is equal to 6 into 10 raised to minus 3. That three values we have. Now rate equation also we have here. Here you can see rate equation is there. Now put the values in the equation. Rate value we have. Here you can see 6.06 into 10 raised to minus 3. So rate value we can put in this equation. Concentration of A, that is 0.1, concentration of B, that is 0.1. Both value we have, and concentration of B raised to 2 here. So we can get k value from that calculation, and that is for equation experiment number 1. Now that value almost here 2 is there, 0.1 raised to 2. So you will get 6 here. K is equal to 6. Make a correction here. K is equal to 6 you will get. Now for same calculation you have to do for experiment number 2, experiment number 3, and experiment number 4. So 4 different k values you will get. Now that 4 values you have to take average at last. That is our required k value, overall k value for the reaction. So you have to do it at your own. Also, yesterday we have calculated examples up to 4.8 number. 4.9 question is similar to 4.6 number. Again, exercise question number 4.9 is similar to question number 4.6. So try it at your own, and if you have any problem you can ask me. Thank you.